Welcome to the deep dive. Today we're heading way back to the late Cretaceous period. We're focusing on a place we now call Big Bend National Park, Texas.
That's right. And we're going to be digging into the science behind a really interesting dinosaur called Angulomastacator, looking at the paper that first described it and, some of the research clues that led up to it.
Now, this isn't just your average dinosaur story, is it? We've all got images of T-Rex and Triceratops, but this one's a bit different. Our goal today, really, is to explore how just one bone, the shape of a jawbone fragment, can tell us so much.
Exactly. It tells a story about unique evolution, about a world very different from today.
Yeah, and we want you to get a sense of the evidence, the reasoning, how scientists actually figure this stuff out from tiny clues.
How paleontology works in practice, piecing together the past.
Okay, so let's dive in. Where do we start? The main piece of evidence, I guess.
Absolutely. It all hinges on this one fossil cataloged as TMM 43681-1. And it's not, a whole skeleton, not even a complete skull. It's a partial left maxilla, so part of the upper jaw.
Just a piece of the upper jaw.
Yeah.
And found, you mentioned, in Big Bend.
Correct. From the Aguja Formation there in the park.
That's pretty amazing what you can learn from just a fragment like that. What about the specific spot it came from?
Well, the paper says it was in the upper shale member of the Aguja Formation. And interestingly, it wasn't alone. It was found mixed in with plant bits, other bone fragments, even clamshells. The geologists think it was basically the deposit of an old stream channel, like a small creek bed.
Like leftovers washed into a creek millions of years ago.
Yeah, bits and pieces of that whole late Cretaceous world.
And you said upper shale member. So its position in the rock layers matters too, right? For dating it.
Definitely. It was found just below the Javelina Formation, which is geologically younger, so that helps pin down its age.
Got it. Okay, so this jawbone piece gets found and needs a name. Angulomastacator. That's quite a mouthful.
It is, Angulomastacator, but it's actually very descriptive once you break it down.
Okay, break it down for us. What does bend chewer actually mean here?
Right, bend chewer. So Angulomastacator, the first part, angulus, that's Latin for angle or corner. Then you've got the Greek mastax, which means jaw or mouth. And finally, the Latin suffix cuto, which means like the one doing the action, the agent.
So angle jaw, doer. Angle jar, bend chewer. Okay, the bend part must relate to the jaw itself then.
Exactly. That's the first reason for the name. The jawbone has this really distinct downward bend.
Ah, okay. And the second reason?
That ties into where it was found, the Big Bend area of Texas.
Oh, that's clever. So it links the anatomy and the geography.
Precisely. And the species name, Daviesi, that honors Kyle L. Davies, who did some important early work in that region.
It's neat how much history can be packed into a scientific name. Okay, so the jaw, the bend chewer. What was so unusual about this bend?
This is really the core of it. The front part of this maxilla, this upper jawbone, it curves down pretty dramatically. We're talking about a 45-degree angle downwards.
45 degrees. Wow, that's sharp.
It is. And crucially, the tooth row, the line of teeth, follows that same curve.
That doesn't sound like a typical hadrosaur jaw at all.
Yeah.
Most herbivores, you picture a flatter, grinding surface, right? What did the scientists make of that?
Well, they stressed that this specific kind of bend, this curvature, it was completely unknown in any other hadrosaur, any other duck-billed dinosaur.
So totally unique.
Totally unique. It was the key feature, the diagnostic trait that told them, okay, this is something entirely new, a new taxon.
It wasn't just a weird individual. It was a whole new type of dinosaur defined by this bent jaw.
Okay.
So where does this bendy-jawed creature fit in the big dinosaur family tree?
It's placed within the Lambeosaurinae.
Lambeosaurians. Okay, refresh my memory. Those are the hadrosaurs with the big head crests, right?
Yeah.
Like Parasaurolophus.
Well, Parasaurolophus is a famous one, yes. But Lambeosaurians are the group known for having hollow cranial crests in general. Think Corythosaurus, Lambeosaurus itself.
Gotcha. The ones with the fancy headgear.
Right. And they all belong to the bigger family, Hadrosauridae, the duckbills, the very successful plant eaters from the late Cretaceous. Mostly walked on 2 legs, but could go down on 4.
And they had those amazing teeth, right? Like batteries of teeth for grinding plants.
Exactly. Stacks of teeth that were constantly replaced. Super efficient for chewing tough vegetation.
So even from just this jaw piece, the features pointed towards it being one of these crested plant-grinding dinosaurs.
That's the interpretation, yes.
Okay, so beyond just naming a new dinosaur, why was this particular discovery in Big Bend so important? What did it tell us more broadly?
It was really significant because, well, first, it was the first clear, undeniable anatomical evidence of any hadrosaurid from Big Bend. People suspected they were there, based on other fragments, but this jaw was concrete proof.
Ah, okay, confirmation.
Yes. But more than that, the uniqueness of the jaw in that bend, it strongly supported an idea that had been floating around.
Which was?
The idea that the dinosaurs in the Aguja Formation in this part of Texas were potentially endemic.
Endemic. Meaning they evolved there and were only found there, like isolated.
Kind of, yeah. That they were distinct species that evolved in that specific region, different from the dinosaurs living further north at the same time, like in Alberta or Montana.
So it wasn't just a variation, it was like a whole separate evolutionary path happening down in Texas.
That's the hypothesis. Maybe geographical barriers, maybe specific environmental pressures led to this unique fauna developing.
Yeah.
And Angulomastacator, being so weird, fits perfectly into that picture of local evolution.
That really changes how you think about the dinosaur world. Not just one monolithic set of species everywhere, but these regional pockets of unique life.
Exactly. Much more complex.
Now, you mentioned earlier work by Kyle Davies. This discovery didn't just happen in a vacuum, right? There's a backstory.
Oh, definitely.
Huh.
The paper describing Angulomastacator acknowledges Davies's master's thesis from way back in 1983. In his thesis, he actually suggested there was a lambeosaurine in the Aguja Formation.
Based on what, though, if he didn't have this jaw?
Based on the proportions of some limb bones and other postcranial bit stuff from the rest of the skeleton.
So he saw something in the shape or size of the leg bones, maybe?
That was his interpretation. Now, later analysis showed that limb proportions alone aren't always a slam dunk for identifying lambeosaurians specifically.
Ah, okay. Not quite definitive.
Not definitive on their own, no, but his basic idea that these types of dinosaurs were present turned out to be right.
So his work laid some groundwork.
It did. And then later, some researchers from Texas Tech found other weathered bones. Looked like they came from a skeleton that had broken up and been washed downstream in a flood. Those finds also hinted at lambeosaurines being around, even before the definitive Angulomastacator jaw turned up.
So it was a process, clues building up over time.
Yeah.
And when did Angulomastacator itself actually live? You mentioned its position in the rock layers.
Right. So based on where it was found and comparing it to other dated layers nearby, specifically a volcanic ash deposit, a pyroclastic flow.
Volcanic ash. Okay, that helps pin things down.
Yeah, those can be dated pretty precisely. That nearby flow was dated to about 76.9 million years ago, give or take a bit. So that puts Angulomastacator firmly in the middle Campanian age of late Cretaceous, around, say, 76 or 77 million years ago.
Late Cretaceous. Always a fascinating time for dinosaurs. And Big Bend seems like it was a really unique spot back then.
It certainly looks that way. This one odd jawbone opened up a window onto that. It suggests that, yeah, late Cretaceous Texas was doing its own thing, evolutionarily speaking.
Okay, so let's wrap up this deep dive. We've journeyed back to late Cretaceous Texas, focusing on Angulomastacator, the Bend Shore, a lambeosaurine hadrosaur, known from this really distinctively angled upper jaw found in Big Bend.
And that bent jaw, that's really the key. It's not just why it got its name, but it was the crucial piece of evidence. It showed it was a totally new species of duck-billed dinosaur.
Right, and finding something so unique there really backs up this idea of endemism. That the dinosaurs in this part of Texas were different, evolved separately from those found further north.
Yeah, it highlights that different regions had their own distinct dinosaur communities. A single bone tells a big story about ancient life, about how local conditions can shape evolution.
It really does. Which leaves us with some interesting things to think about, doesn't it?
Absolutely. It makes you wonder, what else is still hidden in the rocks of the Aguja Formation? What other unique creatures might be waiting there?
And that jaw, that specific 45-degree bend.
Yeah.
What does that actually tell us about how Angulomastacator ate? Was its diet different from other hadrosaurs because of that shape? How did it work?
Those are great questions. We don't have all the answers, but the discovery really pushes us to think about the incredible diversity of dinosaur adaptations and the factors that drove them down different evolutionary avenues. What other unexpected forms of life were out there?